Hello everyone. Today is the 14th day of Leetcode 75 challenge. Let's begin with the 14th question. Question number 643. Maximum average subarray 1. The level of the problem is easy. Now I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let us try to understand the problem in easiest way possible. So you are given an integer array nums of a size n and an integer k, and you need to find a contiguous subarray of length k that has the maximum average value. Now, a continuous subarray means what, right? The elements in the subarray are next to each other without any gap. Okay, so this is an array having some values in it. Mhm. Basically, when we talk about subarrays, usually the subarray could be 1, 3, 4, right? Or 1, 2, 3, 6, right? The order has to be maintained whether they are continuous or not continuous, right? But here they are saying it has to be continuous, which means that if you're taking a subarray 2, 3, 4, it has to be continuous, right? You cannot take anything like 2, then 4, then 6. Okay. The length of the subarray must be exactly k. Now the subarray which you are taking should be of k length. Fine. Your task is to return the maximum average value of such a subarray. Okay, you have to just return the average of the subarray from the given array. That's all. And the subarray has to be continuous. Okay, that is what the question is asking to us. Mhm. What are the constraints? N is a num's length, and k and n value could be from n to 10 to the power 5. And nums of I, basically value in each index could be from negative 10 to the power 4 to positive 10 to the power 4. So these are the constraints. And I hope you understood the question what they're asking to do. Right? Now let's move to the next slide. Now let's understand the input output of the problem. Okay. So given to us is 1, 2, minus 5, minus 6, 50, and 3. And the value of k is 4. Basically, k is 4 means the subarray should be of length 4. Now, the output is 12.75. This is the maximum output, right? So, we can, as you remember, the subarray should be of length 4 and it should be continuous. So, let's take this from 1, 2, minus 5, and 6. Fine, this is one continuous subarray. And we have to find the average. What is the formula of average? Number of elements, it will be divided by sum of elements, right? So the total sum of elements here is 12 plus 1, 13, minus 5 gives and minus 6 addition gives us 11, right? So we have 13 plus minus 11, which gives us 2. 2 divided by 4 gives us a result which will be 0 point something, right? So it is not the answer. Okay. So now let's take for another. Uh, let's take uh, let's take 50. Let's take 50. Basically, let's take the last four elements. 50 plus 3, right? And plus minus 11 because when we add 5 and 6 negative, we get 11. 4. Now we have 53 minus 11 gives us 2, 4, 42, right? Now let's try dividing 42 to find the average. 4. We know that 4 into 10 gives us 40. We are remain with 2 and 4 into 5 gives us 20, right? So 10 to 10.5 is the result for this. So this is also not the output. Now we want the result to be 12.75. Let's try another one. Okay. First we took 5, 6, 12, right? 12 and 1. Now let's take 12 minus 5, this one, 65. So we take 50 plus 12 minus 11 divided by 4. 50 plus 12 gives us 62 minus 11 gives us 151. Okay. 51 divided by 4. We know that 4, if we take 12, 4, 2, 4 into 2 gives us 8, 4 into 1 gives us 4. Adding 4 into it gives us 48, right? So 4, 48. 51 subtracted 49, 50, 51. We get 3. Add here 0, we get 30, right? 7 into 4 gives us 28, leaves us with 2, and we again add 0 here, so we get 4 into 5, 20, right? So our output comes out to be 12.75. Yeah, so this is the maximum we will be getting as the output. Okay, I hope you understood how we got the output for that particular particular thing. Right? We took a continuous array of length 4. We took three different cases, and in one case we got the result. In this case, we just have 5 and k is 1, right? So we'll just divide 5 by 1 and we get 5. That's all. I hope you understood the input and output explanation. Now let's move to the next slide. To understand what the problem is asking, we should build up an intuition to the problem first of all. Fine. Let's begin with it. So let's try imagining this situation in as a slices of pizza at a party. Okay. Now you are at a pizza party and there's a long table of pizza slices. Your goal is to find the best tasting set of k consecutive slices. Fine. It's the same thing. We're in a pizza party and there are multiple pizzas. Let these be pizza slices, right? And we have to just find a consecutive slices of pizzas of any of a x size and tell them which is tastier than the other one or not. That's all. So, what is the efficient way to do it? Let me make here pizzas. Let these be pizzas. Okay. Okay. Now, what is the thing? The thing is that one of the way you can do is that you have to take k size of k number of pizzas at a time, and that has to be continuous, right? Let the k be 3. So the first intuition which comes into our mind is that first we will take first 3 pizzas, right? Yeah, nothing wrong with that. Now, the next thing comes to our mind. Let's take these 3 pizzas, right? Then the thing which is an issue here is that we are left out with the last pizza, right? And also we have left out with this part of the combination, this part, then this part, right? There are multiple combinations here, right? So if we just take 3 pizzas, one after another as a set, it won't give us the correct result. So the second things which can come to our mind is that what if we take this pizza and go for the other 2 pizzas? Okay, that makes sense. Fine. After doing this, now let's take this pizza and move to the next 2 pizzas. Okay. So here what we are getting, we are getting the combinations of each set of pizzas, right? Again, we take this pizza and we try to move to the next 3 pizzas. Sorry, 2 pizzas, not three. Pizza slices rather, right? Yeah. Here you can see that we are getting the combinations. We're taking this pizza and this 2 pizza, we got a combination. Then we take this pizza and these 2 pizzas, we got a complete combination. Then we take the third pizza and the last, and after that 2 pizzas, we got a combination. Similarly, we will come here and this 2 pizzas, we got a combination here. We got a combination here, and yeah, it is done. But the thing is here is that we are doing the repetitive task again and again. Coming to the pizzas and coming to the pizza back again from, if we see it is in a practical way, you took first pizza here and you went here. if a person is working in that way. Now again that person will come back to this slice and again he will go to this slice, right? Then again he will come to this slice and again he will go to this slice. So it's a redundant task the person is doing and it is a repetitive one also. What else intuitive intuition can come to our mind? If you have focused here, if you take this slice, then we are taking this slice, right? We are adding this slice and removing this slice, right? And when we were taking this slice, the third one, we were removing this slice and we were adding this slice, right? Now focus in this part. Imagine you are a person, right? In this case, take a new slice from the right side of the table, right? First you grab three size slices. Now you have hands full of three slices. Now as a person, you will just take another slice for the next round. Now you have four slices in your hand and you drop the slice, you grab the first one. We drop this slice, right? From your hand, you think of dropping the slice which was in the first one. So now you can see that you have three slices. That's all, right? Again, you tasted these three slices, then you went ahead and you added one more slice in your hand. But after that, you removed the slice which was taken previously. So we removed this slice. Now again, you have three slices. Again, you did the same thing. You have this slice, and again you did the same thing till the end. Till you reach the end. Now, when you are taking the slice, right, keep the track of the best average score you have ever had in each round. Right. That's the thing. When you are in this k equals to 3 sub array, you have to take this average. Then you will just add one more slice to it and remove the first slice from it from your hand. Right. Now, instead of calculating the total score from scratch every time, which you were doing just before this, you just had to adjust the score by adding new slice and remove the old one. Now, I hope you understood what we're trying to build up in this presentation. And if you can get a closer look to it, let me pinpoint it to you. We are making this, let's call this as a window. We have three size window. Again, you are making a three size window in this case, right? Then again, you are making another three size window. And if you focus in more clearly, you are just making a window here. Then you're sliding this window, right? You're just sliding this window again. Then again, you are sliding this window by one, right? So from here, we come to a concept or algorithm is commonly used in by solving DSA problems called sliding window technique. Now, this is a very important and crucial algorithm or concept we should be knowing to implement this kind of problems. But before reaching to the sliding window, I hope you understood how we come or make our way to solve this problem using sliding window, right? How we derived that it will be a sliding window problem after removing one element before and adding one element in the after case, right? Now, now let's move to the next slide. I hope the intuition is clear to you. So let's move to the next slide. Before going to the approach, let's understand what is sliding window concept in more deeper meaning or in more deep depth, right? So sliding window is a powerful technique used to efficiently solve problems involving contiguous subarrays or subsequences. I hope you understand what is subarrays, right? If this is a subarray with some values, the subarray for it will be x, n, z. We follow the relative order given in the original array, but it may be continuous or it may not be continuous. Fine. And same case in the case of string also. Now, how it works? First, we define a window, usually a fixed size of k or dynamic size. Window could be a dynamic size also, or it could be of fixed size also. Uh, that could be derived from the question itself, what the question is asking, over a part of the array or string. Now, we just start by calculating the result for the initial window. Now, whatever the calculation has to be done for a particular window, like adding the complete value, taking the average of those of that window, taking the multiplication, or anything whichever is asked in the question. Then slide the window one step at a time Add the new element coming to the new window, which is in the right side, and removing the old element that is leaving the window, which is from the left side. Now keep updating the result while sliding. So it goes like this is the array, and this is one window from start to k size. Now your task is we will add new element, that this will be the new element added, and you remove the last element, let this be the last element removed. So our array just moved by one, right? This is how it goes. Now, why is it efficient to use? Now, instead of recalculating the result from scratch every time, we just have to adjust the result using a new and outgoing element. Just requires O of n time in that. And the total complexity becomes to O of n instead of O of n into k, which you get from brute force approach. Brute force approach is basically you start from I, go till n, k, this is size. Then again you start with I plus 1, and again you go from k times, and this is how you go, right? So this boils down our complexity to O of n. Now let's move to the next slide. Now, variations of the sliding windows. Now, where could you use the sliding windows and what could be the variations of it, right? So let's understand that also. If it is a fixed size sliding window, if the size is given to you, it is fixed that it will be a k of suppose size is always 5 and it won't be changing. So just have 5 and sliding one step at a time and adjusting the result. Use cases could be maximum, minimum, or sum of fixed length subarray. Example is maximum subarray, maximum sum or average of subarray of size k. Now there could be a two pointer variation also. The left and right pointers define the window here, or expand or shrink based on the conditions, like finding pairs, minimum, maximum range. Example could be container with most water. We solved this question in our previous videos. Please look into those also regarding the two pointer variation, container with most water. The third type or third variation will be monotonic sliding window. We use a DQ to keep elements in order while sliding. DQ is a data structure in a nutshell is that we can push and pop from back, push or pop from front. Right? This is DQ. The use case could be maintain a sorted or maximum minimum values in a window. Maximum in each subarray of size k. Whenever you have to maintain a sorted maximum or minimum values in the window, we have to use DQ, and this is called a monotonic sliding window technique. Now the fourth variation will be dynamic size sliding window. We expand the window until a condition is met, shrink if it is violated. Now, expansion of the window is done from the right hand side and shrink is done from the left hand side, right? If we expand it like this, then you shrink it from the back this way. The use case is longest or shortest substrings satisfying a condition. Example could be of the problem longest substrings with k distinct characters. Now the fifth variation will be circular sliding window. Window wraps around an array boundaries like a ring. The array becomes a ring. Fine. Use case would be sum or minimum maximum in a circular arrays and maximum sum of circular subarray. So these are some of the most commonly used variations I have defined here of the sliding window technique. I hope you get a gist of sliding windows and their use cases and examples of the problems I have mentioned here. If it is good to you, please go and look at these examples and you can understand how these sliding window techniques are being used. Now let's move to the next slide. Now, where sliding window is used, okay, in a nutshell, if you see in subarray subsequence problems like having maximum, minimum, average of size k, longest, shortest subarray satisfying a condition. In string problems, longest substrings without repeating characters, longest substrings with k distinct characters, and minimum window substring. Now, pairing and range problem also. Container with most water, sum of two elements closest to zero, number of subarrays with some within a range. Now, frequency counting using set or hash map. Longest substrings with k most distinct characters, find anagrams in a string. Now, I have given you the sliding windows where it is being used here, and these are some of the examples or name of the problems. I have given you the names of the problems and examples where this sliding windows is being used. It is just a gist. So you could go and look at this the problem and understand that how the sliding windows are being used in this kind of problems. I hope you understood the concept of sliding window, how it works, what are the variations of sliding windows, and what are the problems. You could look into it, just get the understanding and gist of sliding window and where the windows are being used. Now let's move to the next slide. Now, since you got the intuition of the problem, let's look into the approach, how we're going to solve it. Step one will be defining variables. One variable will be sum to store the sum of the current window of size k, and another will be result to store the maximum average of the value. Basically, the sum which we will take out, for example, x, uh, is okay x, and the average, and the result will be the average of it. Basically, result will be x divided by k. Okay. What is the second case? We have to handle the edge cases. What is the edge case could be? For example, you are given an array of size n, right? And k is something, let it be n minus 5. Let it be n minus 5, fine? So, okay, so when is a subarray possible? A subarray is only possible if k is 0 to n. Basically, either there is no subarray given to us or the subarray length which is given is equal to n. Because if k is greater than the n, we cannot create a subarray, right, from the n. To understand it more clearly, suppose this is n size array, fine, and a k given to you, the subarray k is given to you, or which will be the subarray basically, is this. You could see this is the extra values compared to n in k. So you cannot use k to make subarrays from n, right? Because subarrays are part of an array of size n. But the size of the subarrays are only greater than the actual size of the given array, which is n in this case, it is not possible. You cannot you cannot take these values, extra values from n, right? That is not possible. That does not exist in n. But if n is n size array is this, and k is size array is this much, right? So yes, you could take out this much values from this given n array, right? Even if the k is equal to the size of n, you could do the same because sub-array could be taken out from the given array itself. So this is the edge case. If k is greater than n, they are written because it is impossible to create a sub-array of size k when the array size is smaller than k. Right? This is only we have to handle one edge case, which is the size of k. The third step comes to be creating initial window. Now we calculate the sum of the first k elements of the array. This represents the sum of the initial window. Now what does this mean? We are given an array of n size, right? So and we understood till now we understood that we have to use sliding window and there will be a size of the window which will be n. Now to make the task much more easier for us, I calculated the k size array subarray of window k size beforehand before going to the main loop. Now why we are doing this? Because this gives us an edge having a sum and also result beforehand. First thing. Now when we will start from the original loop or when the sliding window will actually start, we will be starting from here. This is the next element, right? We will add this, the whatever value is there, to the previous sliding window sum and remove the first value from the window. And now what we got? From here, we got by including this zero or the value, we got a new window from here, right? So this basically makes us our task much simpler. If we have given or if we have done directly started from zero, for example, instead of doing this, what we thought that we will just make one loop, we will not calculate the result beforehand of k size window. Then what will be the scenario will be is that then the scenario will be like this. I starting from here and k is somewhere here, right? So first you have to take this sum, right? Then again it becomes an issue. Then you have to put I in here before k, or you have to put k after the value of k is reached to k plus 1. So this will become a hideous task. You have to take otherwise two pointers in this case. One will be starting from 0 and other will be starting from k. So it basically becomes a kind of tedious task to do. So rather than that, just calculating the k size window sum and average beforehand, we get an what we could say, we get the edge to start it from the kth side. I will explain that in much more clear way in our dry run part. Now let's understand this. I hope you understand this case why I did this. Now we store the average. Okay, now the step 4 is sliding window. We start from index k to n minus 1. As I said, after taking out the sum, we will start from k. We add the next element to the current sum, expanding the window from the right. What we do? This is the sum. We added nums of I, which is basically starting from k. Okay, that is done. From the previous sum plus current value becomes a k plus 1 size window right now. Then we remove the element that is now out of the window. We remove the nums of I minus k, shrinking the window from the left. Now, why we are doing I minus k? Okay, you have to understand that. Okay, suppose this is an array. Let it be 0, 1, 2, 3, 4, 5, 6. Fine. And since I have started it from 0 already, let me mark indexes also. It is this 0, 1, 2, 3, 4, 5, and 6. These are the indexes. Now, I said I will just add the sum of k elements, right? So k is 3. So first we calculated the sum of this 0, 1, 2, right? And when we come to the sliding window in the step 4, the I starts from here basically. K. K is 3, right? But we have calculated a size 3 already beforehand. Now we're starting from here. Okay, fine. Now what it is going to do, it will add 3 also. Now our array or window becomes of size 4. Now what I'm doing here is I'm subtracting I minus k, right? I is what? I is in this case is 3. And k value was what? It was 3. It gives me 0. This is the index 0. This one. We have to remove this element, right? If you remove this element, we got a window of size 3 consisting of 1, 2, 3. So we got a new window. We moved the window by 1 to the right side. We achieved this. Again, if our now this is the window, right? Again, when our window is moved to more right side, let's try doing that also. Again, we did the same thing. Our window came here. Now what? Now i's value is 4, and we subtract 3 from it. We got 1. So we remove this 1 and we got three values again. 2, 3, 4. So this is where we are moving the window to the right side and removing the first value from the window. I minus k gives us the index, which is the first index of that particular window. Okay, I minus k gives us the index of that particular windows. Okay, first index of that particular window. I hope you understood why we are using I minus k. Now let's move ahead. Now sliding the window behavior always allows us to efficiently calculate the new sum in O1 time instead of recalculating it from scratch. Now, after doing that, we update the result again. Result equals to maximum of result which was stored previously by the recent average we calculate. Then at the step 5, we return the result. Now, how sliding window is helping us? I will just want to recall it again. Instead of recalculating the sum of the subarray every time using n into k complexity, the sliding window approach allows us to add one element to the right and removing the one element from the left. So the complexity boils down to O of n. So this is the main reason of using sliding window. Okay. I hope you understood the concept of sliding window, how we are using it in our approach, and why sliding window is beneficial for us. Now let's move to the next slide. The code is the exact copy of the approach we discussed. Let's understand it line by line. We take out the length of the nums array first of all. Then we declare a variable sum and result. Sum stores the summation of the particular window and result take out the average. Fine. And this is the first window we create of size k, right? Then we take out the average for that window. Then we start our I from k till n. Now here you can see we added the new element in our current window and increasing its size. Then removing the first value of the particular window and making the window again shrink to size 3. And we take the maximum of the result previously we got here, then again it will, and the current one which we got now. So it will keep on updating itself and we return the result. Now here the time complexity is O of n. You will be confused that we are using two for loops, but if you consider here this for loop is of O of k size. Fine. The k could be from anything 0 to n. And then we are using O of n minus k size. Since we have already looked k in this case, so we will starting from n minus k, right? These are the elements which will be left. So if we add these two, we get O of n, prime complexity at the end. And the space complexity is O of 1, since we are not using any data structure to store any values in it. I hope you understood the code. Now let's move to the next slide. Now, since you have the understanding of the code, let's look at the dry run of the example. Now, let it be, I will create it much bigger here. 1, 12, minus 5, minus 6, 50, and 3. Okay. Window has to be of k size 4. Index 0, index 1, index 2, index 3, index 4, index 5. Okay. Um, Let us declare S is the sum, R is the result. Fine. And what else we did? Now, first thing was we make a for loop of size where I starts from 0, goes till I less than k. In our case, k is 4. Okay. From here, we just looped it from 1 to 3 index. Okay. The sum which we got is if you add 1 plus 12, we get 13. Minus 5 minus 6 gives us minus 11. 13 minus 11 gives us sum of 2. And the result will be 0 point something when we divide it by 4. Okay. First thing is done. Okay. Now, the main sliding window iterator, which is a second loop, this one, we will start our I from k. K was 4. So our I is here. Fine. Now, what was the formula to calculate the sum was S equals to S plus nums of I, fine, minus nums of I minus k, fine. Now, S sum was 2 plus n of I, which is 50 in our case. Okay. and I index is 4 and k value is also 4. So we got 0 here. So it turns out to be 0th index, fine. And 0th index value is, let me write it down here, 1. So 50 plus 2 gives us 52, minus 1 gives us 50, right? Now if you carefully look here, we have removed 1 from our window, right? So our window becomes from value 12 to value 50. And if you take out the sum of 50 of this window, basically 50 plus 12 gives us 62, and we subtract 11 from it, which is minus 5 minus 6, we get 51. Sorry, it's not 50, my bad, it's 51. Fine. So we got the same value, which means our window is working. Now we got 51, and when we divide 51 with 4, we get 12.75. Now this 12.75 is greater than the 0 point something which we got earlier. Yes, it is. So we will replace this with 12.75. Okay. So first iteration of sliding window is done. Our window will move again. Our window will move from 12 minus 5, 6, and 30. Right? I hope till now you understood why our window moved there. Now, the sum was 51. Need to replace the sum also here. 51. Okay. Now we add 3 to it. We subtract I value is 5, k value is 4. We got 1. 5 minus 4 gives us 1. 51 plus 3 gives us 54. N of 1 is 12, which gives us 2, and 1 minus 4, we get 42. Okay, now we got 42. Now let's calculate here. 50 plus 3 gives us 53, correct? Minus 5 minus 6 gives us 11. We subtract it, we get 42. So yeah, our sum of the sliding window is exactly what we want. Now our condition was to divide it by 4. So when we divide it by 4, we get 10.5, which is smaller than the result average which you got previously. So we cannot use it. And after that, our iteration gets completed, and the result which we got is 12.75. Now, I hope you understood how sliding window is working, and in each window, how we are calculating the sum, and how we are removing the elements from the beginning of the window, or the first value of the window, right? If you have not understood anything, or if you have doubt in any of the code or approaches, I will request you to go through the intuition, then the concept of sliding window and its variations, then deep dive into the approach, how we are doing it, then look at the dry run again and take 2, 3 examples of your own and do the dry run again itself by your own. I hope that will help you understand how the sliding window technique is working. Now let's move to the next slide. Now since we are familiar with the problem and the solution, let's move to the lead code and code the solution. First and foremost, we have to take the length of nums array. We'll declare sum variable and result variable to store the average and the sum. Now for I in range, we'll go up to k. This is our first window sum. So nums of I, and result will be sum divided by k. Now we'll start from kth value. For I in range k comma n, sum equals to sum plus nums of I, nums minus I minus k. Yeah. And also keep in mind, the I will never be greater than k. It will be equal to k or greater than k. So don't worry about the negative value you will be getting. Max of result or the current sum which current average which we got, and then we'll return the result. We have successfully passed our test case. Now let's submit the solution. Yeah, our solution got accepted. Now, code of the problem is available in my GitHub repository. You can find the link in the description. Thank you, everyone.